Alright, so in this test we're going to run in ANOVA. We have two variables. We have a meeting method, which is when students met with their instructors, I think it's a math or science instructor, either met one, the first level is that they were in the instructor's office, the second one in their classroom, the third one was no meeting. So that's our independent variable. Our dependent variable is the exam score, which is a scale, whereas the independent variable is a nominal measure. So the first thing that we do is to make sure that we are not violating any of our assumptions. Our data is not violating any of our assumptions. So you can see here, these are the students' scores that were met in the office, classroom, no meeting at all. So first thing we're going to do is we're going to go to Analyze, Explore. Here we're going to put the meeting method, which is our independent variable, into our factor list, and our exam score, which actually I should change that. That's really kind of confusing with instructor exam score. Hold on. Okay, so I just changed this data label here because it was the exam score label was like in office or something like that, which was confusing. Shouldn't have been there. So we'll go back to our data view. We're going to go to Analyze, Descriptive Statistics, Explore. We're going to take our meeting method, that's our independent variable, and our exam score is our dependent variable. Statistics, we're going to include outliers. Our plots, we're going to leave the box plots, factor levels together, stem and leaf. We're going to run this normality test, normality plots with tests. Tell us our data is normal, and then we're going to do untransformed. Continue. Options, we'll keep that, exclude cases listwise. Continue. We'll paste that into our syntax. Then we'll go ahead and highlight that and run it. This is our output file. So in analyzing this, looking to see what it tells us, we don't have any missing cases. We see the means are a bit different, especially between in-office and classroom and no meeting. Which in this particular case, that's what we're mostly interested in, is if there are difference between those students who met with the instructor in their office versus those who met in the classroom or no meeting. So we're going to also look for the normality of our data, meaning that it fits that standard bell curve. And our skewness and kurtosis value should be between -1 and 1, so that's a little bit off, but not anything to be afraid of. Again, a little bit off, not anything to be afraid of. And this one right here is a little bit nothing extreme, but something that we'll probably see later. Here, our extreme values. So our test of normality, we don't want any of these to be significant. If they are significant, this sig value right here, that means that we're violating our assumptions of normality. So our value is at 0.05. So this one does not violate. This one does, because it's actually less than 0.05. So that's could be a problem. We'll check out our QQ plots next. And this one is not statistically significant. This is another test, homogeneity of variance. We have no significant values here, so we do not violate that assumption. Here we're looking at the different methods in office. There's no extremes or outliers here, which is good. Here we have two extremes, which were less than 65. And here we have one extreme at less than 64. So our QQ plots looks pretty good. We don't have a lot of cases, so it's a little bit different. Here these are deviating at the tails. Again, deviations, so it's probably an outlier there. And we're not really concerned with this detrended normal. So here are our box and whisker plots. As we saw two extremes and then one extremes, which is probably responsible for, or is responsible for our skewness and kurtosis being off a little bit. So because we don't have very many cases, we probably won't eliminate these outliers, because that would cause our power in making generalizations decrease. So we don't really want to do that. So that's sort of the first step, is making sure that we don't violate those assumptions. So we've got normality, homogeneity, variance. Is there another one? I'm not sure. Well, if there is, we'll come back to it maybe. So the next thing that we're going to do, is we are going to go to Analyze and Compare Means. We're going to do our One-Way ANOVA. We're going to add our exam score to our dependent list, that's our dependent variable, and our meeting method to our factor list. We can either do contrast or post-hoc. We're going to do contrast here because that was the one I had most difficult with. So this, shut up. So this is where we distinguish our contrasts and we assign them coefficients. So I'm going to tell you first what to do. It's all about the position of these. So let's go back here for a second to our data, our variable view. It comes back to these values right here in our independent variable. So this is the first position, so in office. So whatever's in the first position in those contrasts is going to refer to the in office. This is in classroom, and this is no meeting, the second and third position. Okay, so we're going to go here, compare means, One-Way ANOVA. That goes there. Oops. That goes there. This goes here, our contrast. So we want this coefficient total to add up to 0. So what we're going to do is we're going to do 2. We're going to add. These numbers are pretty much arbitrary as long as they add up to 0. And what is really important is where they are position-wise. So this 2 is going to refer to, it's going to stay in that first position. It's going to refer to in office. This -1 means that this is going to be contrasted with that. Refers to our in classroom. And then another -1 because we want this to add up to 0. Good. So this is basically going to say it's going to run contrast between the first position here, which is our in office, with our in classroom and no meeting. Okay. Options, we'll have a couple of these here. I'm not exactly sure why, but I think that's what we do. Continue. It'll show us some extra stuff. We'll paste that into our syntax. Come here, run it. Okay, so these are our descriptives. I guess we didn't really need that. We already kind of knew that, but it helps us to refer back to sort of the mean score is probably going to be the most important here because we're going to hopefully see some significance. Well, not hopefully, but we'll see. Homogeneity, we already kind of did that one. Here's our ANOVA test. There is significant. And then here is our contrast coming down here. Other significance here. I think this is referred to our omnibus. I'm not sure. Here's our contrast coefficients in office. That was the first position, contrasting with the meeting method in classroom and no meeting. And here we see a significance. So the exam scores were significantly different when comparing this in office, the scores of the students who met with the instructor in office, comparing to those who met in the classroom and no meeting. So our initial research question was if there was a statistically significant difference between the scores of those who met with the instructor in office versus those who did not meet with the instructor in office. And here we can say that there was a significant difference. We can refer back to our means here. They were significant in that those students who met with the instructor in the office had statistically significantly higher exam scores than those who met either in the classroom or no meeting at all. So that's what you're going to report.